Welcome back, everyone. Today we are going to be solving this trigonometric equation, so let's dive in. Okay, so first things first, this is basically saying that the trig ratio, sine of 2x minus pi over 4, is equal to 0. So we need to find out where would that be the case? Where would sine of something be 0? Normally, I would say we should use our special triangles, but 0 is actually not part of the special triangles. So instead, what we're going to do is we're going to use the parent function graph. So I'm just going to paste that graph right here. This is the graph of the parent function, right? This graph is y equals sine of x. Okay, so where would this be 0? Well, it looks like it's 0 in these places, right? At 0 itself, at pi, at 2 pi, etc. And keep in mind, this sinusoidal function continues this way forever. So at 0, pi, 2 pi, 3 pi, 4 pi, etc. And we could even go backwards a bit and say also negative pi, also negative 2 pi, etc. Right? And so these are essentially all the values for which this is the case. Now, this is an infinitely many values, and so if we try to individually come up with all the solutions, we'll be here all day, because then I would have to equate 0 to 2x minus pi over 4, and pi to 2x minus pi over 4, and then 2 pi to 2x minus pi over 4, and we would be here all day. So instead, I'm going to come up with a general equation that encompasses all of these values. These values, and all the values above and all the values below, right, included in our ellipses here, can be summarized by saying k pi, such that k is any integer, right? And so therefore, I'm going to argue that sine of k pi, right, is equal to 0, as is illustrated on this graph. And then all we need to do is equate both of the both of these, since here they're saying sine 2x minus pi over 4 is 0, and we know that sine k pi is equal to 0 for all integer values of k, so we just need to equate these two values and solve, and we will have our answer. So here we have 2x minus pi over 4 is equal to k pi, such that k is any integer. Now I'm going to add pi over 4 to both sides to get that 2x is equal to k pi plus pi over 4. And then last but not least, I'm going to divide both sides by 2 to get that x is equal to k pi plus pi over 8, or sorry, k pi over 2, since we're dividing by 2, plus pi over 8. And this is our final answer. Oh, and I should mention such that k must be an integer. And so there we go. Now in one simple equation, we're encompassing all the times where this is going to be 0. X would have to be k pi over 2 plus pi over 8. And for any integer value of k, that will hold. And that's the solution to this equation. Now, let's say we were given a certain domain to work with. Let's say they just wanted the ones in the first quadrant. Well, then we would plug in certain integer values for k to get just the values in the first quadrant. So we could plug in 0 and say that, x would be pi over 8 in that case. We could plug in 1 for k and say that pi over 2 plus pi over 8 would be the case, and figure out what that is and simplify that, and so on. And so if we are given a certain domain to work with, we only want to plug in certain values that would actually encompass that domain. But when we're just asked to solve this in general, leaving it like this is a good plan, so that we have encompassed every single possible value that it could be, even when there are infinitely many. All right, well, as always, feel free to leave any questions in the comment section, and we'll see you for the next one.